probably talking to her until 2 o'clock. Exactly, because you're on WhatsApp talking to her, weren't you? Weren't you?
But I didn't finish my version.
This really early, so.
Don't get a girlfriend. It's too much trouble. Yesterday in math class, he did no work. No work. Okay, let's. Yeah. She's much smarter than him. He's very lucky. All right. Let's see. Atoms. Okay. So last time we finished that yesterday. The photoelectric effect, wasn't it? The equation from Einstein, which won him the Nobel Prize.
I don't like that.
Which you don't like, yeah. That's okay. I'll tell them. HF plus work function, isn't it?
Yeah. Speak about work function.
Yes. Speaking about work function, yes.
How to change the unit here? We say you can change unit on
Yes,
calculator.
yes.
Where? How? What?
Slow down. What unit do you want? Look.
Work function to.
No. Electron volts to joules.
Yeah.
Look. Electron volts to joules, and then joules to electron volts. So when you want to go from joules to electron volts, you divide by E, and when you want to go from electron volts to joules, you multiply by E. And E is on your calculator. Yeah? Yeah, whatever. Is that that's okay, isn't it?
Yes.
Right, we'll continue then. We stopped. Oh yeah. Did anybody watch the videos?
No. I did the photon video. It's last year.
Yeah. So.
Video. I think it's a new video, but not.
No, no new videos. Okay. So next. Well, I don't know. Maybe we could watch the video. But anyways, I don't think we have to watch the video because you did the active listening. Did you watch the video, Sophie? No, nobody watched it. Okay. Well, I don't think we have to because you remember from the active listening. Yeah, when you have an electron, it can behave like a wave. Maybe that's not too surprising because we said that our wave for light, we can think of them as photons, which are particles. So this point is a particle can sometimes act like a wave, and a wave can sometimes act like a particle. So for example, light is a wave, but it can act like a particle because you can have a minimum light.
What do you mean?
It's not really a particle, but it acts, pretends to be a particle. Because if, like, for example, look. This wave here, and then it's smaller, and then it's smaller, and it's smallest. Is there a smallest? There is. And what do we call this smallest? Which I said is like an atom of light. So what I mean is light can do things like a particle can, and particles can do things like a wave can. So an example is like an electron. It can interfere like a wave in the double slit experiment. You remember the double slit experiment from the active listening? So you studied this last semester, the relationship between particles and waves. That sometimes what is a particle can act, what is a wave can act like a particle, and what's a particle can sometimes act like a wave. It's not such a clear difference all the time. Yeah? Okay. So comes along de Broglie, and de Broglie has a formula. He says here, when it's a person. Yeah. So who is de Broglie? De Broglie said that an electron, it's not just an electron, but it's usually an electron or any small particle, may act like a wave. And the wavelength of the wave it's pretending to be, you can find it from this formula, h over p. What's h? Planck's, no, Planck's constant. Remember from last class?
Oh, yes.
And p is momentum, mv. So, wait, before you write it down. You remember the double slit. So the electron comes in and then it acts like a wave. So it has a wavelength here. This wavelength here is related to the mass and the velocity. So if I make the momentum bigger, what happens to the wavelength? It gets smaller, yeah. And if I make the momentum smaller, the wavelength gets bigger. Yeah. So this is de Broglie's formula to calculate the wavelength of a particle. Does that sound too strange?
The name is
It's just
Does the name start at a D?
yes. D-E-B-R-O-G-L-E. The D is small and the B is big.
Why?
I think it's French.
That makes sense. I know nothing about
Not even one word?
it.
Bonjour.
And then,
You know, some other French words. Croissant. Yeah.
no idea.
You don't know croissant? My goodness, you know croissant. Yes.
What's that?
What's croissant? Ah.
She doesn't like bread.
Ah, you don't like bread? You're strange.
Yeah, I like rice.
No bread?
No, I didn't actually. When I in China, I didn't eat bread. No bread and less noodles. Most of that is rice.
You have an interesting diet.
Because I'm from South China.
Ah, people from South China. They're a little strange.
The North China.
Not North Korea.
North China like bread and dumplings.
Oh, I see. North China, bread and dumplings. South China,
South China like a
rice.
rice noodle and some people like Italian food. Very little in the plate. Big plate and very little food.
Cheap.
Not and not cheap.
Expensive?
In like Shanghai.
Ah, very expensive.
Yeah, and
Very.
in North China, exact capital, and in there,
Yes.
and it's big plate, big food, and cheap.
Sounds like my part of China. Big place, big food, and cheap. I like it. Okay, did you write this down? Yes. Okay, we'll have a look at this question and then that's it for the last part here. So, this is like the active listening you were doing. An electron gun.
What do you mean? Toward a screen monitor?
Yeah, this is like the active listening. It's 1 meter away and it fires at the screen. Oh yeah, so I don't forget. I will have you for maths after this class in D207.
Are you going to England last week?
Yes, I went to Northern Ireland last week. Do some cheap shopping. Good. They had a sale in the bookshop. The books were only £2.
How much is per euro?
€2.50.
Oh.
So I got 6 books.
And then?
Then I went clothes shopping. Got some trousers. So cheap, £2. Like, oh my goodness, I'll get this and this and this and this and this and this.
What book did you buy?
Maths books.
Wow.
Maths books and computer books.
The big book. That big and that heavy.
No, normal size.
We're talking about
Maths.
math.
Maths. 2 maths books and 1 computer book. Yeah.
My mom did computer science in college,
Hmm.
when she's college student. But she forgot everything already.
Alright. Maybe her children make her too stressful and she forgets.
Yeah.
Yeah.
My brother and me.
Of course, yes. Okay, did you write this down? Yes? Yes, okay. So let's have a look at this one. So what you have your electron gun and it fires the electrons, but you know that the electrons act like a wave. And they pass through the double slit. I'll put the double slit here. And this is 1 meter. And this is the screen. Right, so the first question is, what is the wavelength? So if we use the Broglie formula, it's h over p, which is h over mv. What did I say the v was? 0.9 c.
0.1 C.
Oh, 0.1 c. Of course, the 9 is too big. Right. So let's put this in on the calculator.
C is here.
Yeah, speed of light is 28 mass of electron. So you get 2.426 times 10 to the minus 11 meters. Oh, Harun, can you move it a bit to the left? Yeah. Will do. Is that okay? Right, what do I ask for the B part? I think it was here. The first order, was it first order diffraction? I want the angle, the theta. Okay, do you remember the formulas you use here?
No.
Yeah, ND, N lambda. You should remember this because you were here for this part, Andy. N lambda equals d sine theta. So, theta is sine inverse n lambda over d. And here, what's the n? If it's the first order.
1.
Yeah. And the lambda I have. And the d, they give it in the question? 10 to the minus 10. Okay, and C. The fringe separation. Yeah? 10 minus 10. In fact, the fringe separation, you could work it out from a triangle. Here is n equals 0, here is n equals 1, and here is 14. Yeah, there's another formula too we'll use. This is 1 meter. So this one here, we'll call it x. Yes. So we can say tan 14 equals x over 1. So x is tan 14. (25 centimeters). But you're right, there's another formula, if you remember it, it's lambda equals xd over d. So you can use this formula as well, or, so x equals lambda d over d.
What is lambda in question?
It's part A.
Oh.
And if you use this formula, you get 24.3 centimeters. So it's nearly the same. In the exam, they don't mind which one you use. But in fact, this one, I think, well, no, both are fine. You remember that this formula here, well, I don't know if you remember, but this formula here, it's only approximately true. But in the exam, they don't mind. It's fine to use it. Okay. Continue? Yes? Okay, you got that? Right. So, we'll do this homework next time, but we'll do the homework from last night